Hey there, so I'm just going to talk about the demo that I built for the project for this subject. So there's quite a lot to talk about, so I'll just start at the start. So the start is probably, from my perspective at least, the hardware. So in general, this project is taking a sensor reading, putting it in storage somewhere, and having someone sit on a UI and retrieve the reading and present it hopefully in some nice to read manner. So the hardware is, the idea is for these sensors to sit on tanks, so they just take levels off water tanks. Any liquid will work, but these ones specifically was for water. So I've got these three sensors. They are from Milesight. They're ultrasonic sensors. They're EM310 UDLs. They measure distance. They measure their own. They're also battery powered, and they communicate over a protocol called LoRaWAN. So it's like a really low power, long range wireless signal. So they have batteries, but they last quite a long time because the protocol is quite low power, and they can communicate over large distances, which is handy if you have a farming field and your tank's very far away from mains power. You can put a battery powered sensor out there and it's going to last a while. And you don't have to have telecommunications like 3G, 4G, 5G. It will communicate over this LoRaWAN signal instead. So in order for that to work, you obviously need the sensor to be compatible, but you also need this thing called a LoRaWAN gateway. LoRaWAN gateway propagates a signal and communicates with these devices. So you have to hook that into that device. This LoRaWAN gateway is a UG65, and it sits on your house or whatever, somewhere with mains power and an internet connection. So that's the hardware. These three sensors, ultrasonic sensors, that connect back to this Milesight UG65 LoRaWAN gateway. So these ultrasonic sensors that communicate over LoRaWAN, and they're communicating back their signal readings to this UG65, which is a LoRaWAN gateway. In order to get this LoRaWAN gateway to work, you need actually a bunch of infrastructure. You need LoRaWAN servers. There's like 4 different types of servers you need for this thing to work. Anyway, you can get them all for free by this provider called the Things Network. They provide an enterprise thing, but this one is just the free option, the one that I'm using. It's just the free option. You have to register your gateway with the Things Network, which basically makes it a public gateway. It means that almost anyone can use it, sort of. You have to also build an application that is attached to your gateway. So in order for these sensors to communicate with this gateway, they have to be registered with this gateway. So you can see here, this is the screenshot from the actual screen that you use to do it. So you can see here I've set up 3 sensors, and they have device identifiers, and they have a join unique ID, which helps them join literally called the join server. And then they can start publishing their device readings up to this, basically this service provider, this server, through this gateway. So that's sweet, right? Now all my readings are coming from the devices. I've set up my devices to be hooked up to this application. I've made this application attached to this gateway. All my devices have successfully joined onto this join server, which is actually non-trivial. You have to use a piece of software to get these devices to attach. You have to give them the correct settings. And once you do all that stuff, your device readings will be sitting in the Things Network server. But that wasn't really sufficient for what I was trying to do. I wanted to provide not only the latest reading to the user, I also wanted to provide history on the reading, so that if a user has some inquiry about the history of their device or something, they want to go back 2 years and see how much water was in the tank, or something happened 2 years ago and they want to see this event in their plot, I wanted to be able to provide this. So what that meant is I needed to create my own storage solution, and what I did is build it in AWS. So the first I'm going to talk about the AWS backend that I had to set up for this to work. And then I'm going to talk about how to connect the Things network to AWS, which is basically just a webhook, a forwarding thing to a specific, you can see there in the base URL, that's my API gateway URL. So I built this AWS backend with a tool called AWS CDK. It basically lets you build out all of your AWS infrastructure in code, and you can also build out logic in the same repository. So it's really like quite powerful. You can build, it's a really modern framework, and you can if you ever hear the term like serverless infrastructure, pretty much all AWS serverless infrastructure is built in this way. Sometimes you use other providers, but anyway, I've used AWS CDK and Python. So the backend consists of these services, right? There's a piece of compute, which is, in my case, I'm using a thing called a Lambda function. There's storage, so that's where I'm going to actually hold the data that I'm processing, the device records, and also the measurement records for each device. So that's in a service called Dynamo. And then I have a thing called API Gateway, which actually provides the service on top of the compute and storage that lets it communicate, lets all this information be available over the internet, right? So API Gateway is like a mechanism to query your internal AWS resources over the internet, just like any other API. It's a gateway into building your API. And then there's like client libraries, which is basically Boto3, it's called. It's a Python library. I've built this thing in Python, so it's a Python library that lets you communicate and basically use all of the infrastructure that AWS has built on top of their physical infrastructure. So like I can instantiate a Dynamo client, and I can make calls to this Dynamo table with all the functionality AWS built in this client library. So that lets me do things like query this table, various other things. So you can see here, this is actually the project structure. So I will go in depth about the actual project structure, like how this thing works in the backend. But this is just a quick snapshot of like sort of the gist. So you can see in here, like in the infrastructure folder, there's the API. There's a user pool, which is like a security mechanism. And there's the infrastructure stack, which actually defines all the lambdas that sit at the end of API endpoints and all the storage. It also defines the storage like data model, or the basis of the data model. So really what I mean by that is there's a partition key and a sort key. You define those two things in the infrastructure stack. Inside the API.py, there's definitions for these lambdas, and it points you to these build folders. So when I build these lambda functions, that API gateway folder down here comes into API endpoints. If I'm building the get device reading, it'll go here, and it will build out this Lambda function based on some configuration that I specify in the Lambda build command, basically. So that's the very quick gist. The last part of it is like, so that's sweet, right? I've got all these readings coming into the internet somewhere. I'm putting them in somewhere very specific with a specific data model so that I can query them the way that I see fit. And then I want to put it on the front end. So for the front end, I used the infrastructure deployment is using Docker, but the language is Python, and the framework for the language is a thing called Dash by Plotly. So it makes it really easy to like build out like pretty aesthetic front ends. And it's fully compatible. It's built on a thing called Flask, so it's fully compatible with other like Docker. If you want to run it on a web server like Nginx, it's totally capable of doing that. And in fact, that's exactly what happens on AWS. And there's other web servers that I forget the name of, but it's compatible with like the vast majority of the large ones. And this is like what the front end actually looks like. So this is one specific device, and I'm reading the distance like metric. So the latest reading for this particular device is 1653, and you can see the full history here. So this line chart basically documents the past month or so of readings. So this, yeah, okay. So this is basically showing, this is the like endpoint, right? Very basic. I just want to tell someone you've got this much water in your tank, and oh, here's what it looked like for the past month. If you're concerned about anything, or you can start trending things and see your usage or whatever the case is. So that's the gist, right? That's the very quick gist. So how am I going to demo it? Basically, I'm just going to show you various screens. It's quite hard to actually show this doing anything because it just it doesn't physically move. It like takes a reading with an ultrasonic beam and sends it over a wireless communications protocol, so you can't really physically see anything, except that you can see this forwarder passing that information into the AWS Dynamo storage. So yeah, I'll show you the screen for the live data. Maybe that'll show something. So this here is my application. You can see that at 10:50, it's 11:01 now. These are publishing every half an hour per sensor. So there's actually a few different, it doesn't look like every half an hour because there's more than one sensor. But yeah, different sensors, tank 2, tank 3, blah, blah, blah. Yeah, so 10:50 was the latest one. You can see there's like a full history of like the publish thing here, or sort of full history. It doesn't actually keep a full history. It actually deletes it every so often. But you can see that it's publishing successfully still, and that's like today. And it published, this is its payload that it took measurements from. So the device is internally turning on, taking a measurement, turning on, sending it, and turning off again. And that's more or less how most LoRaWAN device class A sensors work. So this is the thing stack part of the diagram I just showed. I'm going to move on to showing the backend infrastructure and talk about that a little bit. So this is the backend. The largest component in a AWS CDK deployment is a thing called a stack. Inside the stack, you define various other pieces of infrastructure. So you can see here, this is literally the stack definition, just one line. I've bootstrapped my computer to AWS. Well, first I signed up for AWS, bootstrapped my computer to AWS, downloaded Docker, downloaded like various things, Python, Node, basically set up my computer. You can just follow an online tutorial. It's not that crazy. Set up a few things, and then you can start actually writing the AWS CDK code. So there's templates you can build from. So this is like, you can get this pretty much for free, but then straight after that, it's sort of like build your own adventure. So inside here, you can see I've got an AWS, a bunch of stuff, right, basically. So inside this infrastructure stack, it's a class just like any other Python class, except that it inherits from this thing called stack, so that it can implement other stack functionality. So you can see in mine, I've got an app table, which is literally what I said before. It's specifying the partition key and sort key, which together make up the primary key of a Dynamo table. I've also got an S3 bucket, which is effectively just file storage in AWS world. And you can see I've specified an API in here. So I've got this security user pool. Cognito is a provider of security things in AWS. A user pool is a mechanism that you can use to authenticate. And it's like really good. It's actually crazy how powerful it is. And I'm using bare minimum. But this is the provider of the security. In the API, this is where I can, so API class, inside here, just like any other class, I've got various things. And this is actually where the compute logic gets built. The infrastructure for the compute logic gets built, the Lambda functions and the API gateway. So this is a REST API, pretty modern type of deal. So the gateway is defined here, pretty straightforward. Just give it a default Lambda. It doesn't. This one doesn't actually do anything. It just has to. You just have to provide it one so that it can build successfully. And then you can see I've commented some stuff, and this one is actually the webhook. So TTN passes a bunch of information forward. This one here, this Lambda function here, takes the reading and puts it in Dynamo successfully. So in order to do that, I had to pass in the Dynamo table so that this Lambda knew about it, and I also had to give it permission to write to this table and also to the file storage. Similar thing for the rest, right? The rest, this one here is getting a device reading. This one here is just a mechanism to get all the devices. So you can imagine, like, I would like the front end and the back end to be totally separate from each other. I don't want the front end to have all the information about all the devices. The back end should have that information. The front end wants to query that information. So there's a mechanism for it to do that. It's this Lambda function. It gets all the devices. And then it can pass that information into the get device reading call, and it can get readings for that device. And also, and it can get the current reading and also the history of readings. More permissions. This is actually the API definition. So you can see here, the first one's just an example, but this one here is actually a route. So there's the API. The base route is just like the actual base URL. Then I'm doing /device. I've allowed two methods on this, post and get. If you post to device, you're posting a device and potentially its first reading if you pass that up. And the second is a get, and it lets you get all the devices. This one here is another route on top of the device, so it'd be like /device /measurement, and I've allowed only get on this, so it allows you to get a measurement. So that's the whole thing. That's the whole API definition. 3 Lambda functions. So those Lambda functions look like this. So the first one is the post. You can see in here, I've got a few things. So this is just a mechanism to test it locally. You can run this file and it will run the Lambda function. This thing here is this decorator wraps the error responses. So it lets you do things like return 400, 500, 403, whatever the case is, instead of, this is just a way to unify your response handling, basically. If you look into it, it wraps a function and returns specific codes based on errors that I raised during the function execution. So it really simplifies error handling. Anyway, this thing also runs the main function. Main function is this thing. This is where I'm actually taking the information from that TTN folder, building up a device, and putting it in the Dynamo table. So if we just look through, this thing here is taking this event, looking at what's in there, and passing you back a payload. So it's a really nice way to unify event processing. If we just look inside it, it literally just checks. So all this stuff is AWS specific, but it takes out the query string parameters if they exist, the path params if they exist, and the body if it exists, and loads it into a Python-friendly way to interact with things. This one here is very specific to this endpoint. It pulls out the device unique identifier. Same as this, it pulls out the device name, or in this case device ID, I've called it name. This Dynamo class here is just a bunch of methods for interacting with Dynamo. So you can see, as I mentioned before, there's a client library, Bot03. I've used Bot03 to do interactions with this Dynamo table, right? So some things I want to do are like get items. So you can imagine there's a table somewhere. I want to retrieve information from it. This type of call lets me do that. This is the most basic one. So this is get items in a really basic case. This is get items when I want to do something a little bit more complicated. This is the one that actually retrieves the measurement readings. This one puts items in there. Sorry. No, that's exactly what it does. And updating item. So there's basically just like a CRUD thing, like create, read, update, destroy. I haven't done the destroy, there's no deletes here, but creation is put, reading is get, and update is update. And there's a couple of different gets because it gets a little bit complicated when you have a data model like I've built. So that's the Dynamo class. There's this class here, right? This is the actual model name of the device I'm using. So I'll just show you that. So this is actually quite a complicated hierarchy, class hierarchy, but whatever. So the devices, in order to be put into Dynamo, it helps if they know how Dynamo is kind of working. So Dynamo has a PK and a SK, partition key and a sort key. My devices need to fit into that data model fairly easily if I want to write minimalist code, it's easy to maintain, blah, blah, blah. So the way to do that, the way that I've done that, is build out what would a device look like in general? How would a device in general fit into this Dynamo model? And that's this. It has a record type, has a type hash device. And that would become the partition key of the Dynamo table. And you can see that my specific sensors, the EM310 UDLs, inherit this structure from temp device. So that means like if I had another device model, not an ultrasonic, something else, I could also inherit this structure and not have to rewrite the whole thing. But then it does have some specifics about this ultrasonic, right? So this device EUIs are specific to like LoRaWAN devices, right? And probably specific to LoRa TTN, I'm actually not sure. But so what that means is I don't have to specify this on every device. The device EUI is specific to this type of model, so I can, make that discernment. Metric map. Maybe there's a device that doesn't have multiple metrics. Maybe the device only has one metric, so this metric map would look different. Or if this wasn't an ultrasonic distance thing, maybe the distance wouldn't exist. So this metric map is, all these attributes are just specific to this device. Posting a measurement, it takes it because of the way this device gets information from TTN, or like passes it from TTN. This processing happens in a very specific way. Various other things, right? If I want to do specific stuff on this device, all those methods are defined in this thing. So that's pretty much what this thing lets me do. Lets me instantiate this type of device with specific details. And then I want to put it in Dynamo. So there's a method that lets me like change my class representation to a Dynamo object representation, and that's pretty much what this thing does. And then I'm actually calling like put item on it, so it puts it in the Dynamo table. And you can see here I'm just like this also works for, like I mentioned before, you don't have to pass a measurement up, but if you do pass a measurement up, so you can imagine a device comes online for the first time, it gets turned on, the first thing it does is take a measurement and post it. So it would be a huge pain if you've got this device, you've registered it on TTN, you've done heaps of stuff to get it working on TTN, and then you also have to register it on this platform. So this avoids that. Basically what it does is takes the device, the first time it posts, it'll come to this endpoint, and if the device exists, it'll just put the measurement in, and if the device doesn't exist in the database, it'll also put the device in the database. So that's the gist, right? Yeah, that's pretty much the post device reading, Lambda function, and endpoint. Similar thing here. So I want to, I'll just do get devices first. It's more general. So this one here is much simpler. It literally just, similar thing for here. Takes the payload out of the event, defines a Dynamo class, does get items for all of the type devices and returns them. So this is fine for my application. It would break in the case that you had multiple users with different devices registered for each user, but that would be fine. We could just add one little thing into the Dynamo call to get the specific user devices. But anyway, neither here nor there. It just gets devices. This one here is pretty much a similar thing, except that it actually filters, it gets the measurement readings for a particular device, and I also had to specify a particular metric because, as I showed you before, these devices have like multiple metrics, 3 in this case. So you have to pass up an ID and also a metric, and it will pass back all the latest measurements for that specific device and its metric. And I think it's like 100, the latest 100 readings. So that's the backend. Storage, compute, make it available to the internet, and a data model that allows efficient querying of Dynamo so that I can retrieve the information that I'm looking for. So making that data model was probably the hardest part of this backend. I mean, getting set up took a second, but writing Dynamo data models is fairly non-trivial. Cool, I'm going to show you the front end now. So this is the front end. You can see, hopefully you can see the folder structure here. I've called the commissioning front end. There's a front end folder that actually contains the front end. So like the UI components, the callbacks, various other information about the front end. This larger structure has things about, well, the workspace, environment file, Docker Compose, which basically lets you specify how your Docker thing should be built. So you can see that I'm pulling an image from Docker, which is this clean dash image, and I've specified some environment variables, but these actually aren't used here. It runs on this port in Docker too. There's a README and to-do for me to keep it, track, but the real gist is here. So there's this app.py, and this is like the entry. Sorry, application.py is actually the entry point for this thing. So there's actually quite a lot here. It's because it's been built to allow for like multi-page, and it's not just the front end, it's totally communicating with the back end. So there's quite a few things here, but this first page, application.py, is basically a routing page. So you can see here, if in this path name comes directly from the URL, if that is equal to the home page location, then it takes me to home.layout. This is an error handler, basically. So if you try to go somewhere that isn't defined, it spits out this 404. So I'm going to just go in order. So this takes me to home.layout. So what's that? Home.layout is this. Home.py, the layout variable. This specifies what the front end actually looks like. So in the screenshot, you can see that it's running at the moment. In the screenshot that I showed at the start, this is like the layout definition for that screenshot. You can see here that there's rows, columns, there's a HTML div, there's some headers. I'm specifying the width of the column, and same here. How to justify, basically layout details. There's an interval component, so this thing actually updates itself. But anyway, you don't have to click refresh every time you want this thing to show you the new readings. It goes and fetches the new readings every 120 times 1,000 milliseconds. So what's that, 2 minutes? Something like that. Yep, so home.py. So that's the layouts, the display specification, basically. Then you'll see I've imported these callbacks. So callbacks are intimately linked, the home.callback, home_callbacks are intimately linked with the home page. Home callbacks look like this. So you can see that I've got these IDs, right? This div has an ID. This div, well, actually it has a graph in it, and that graph has an ID. So anyway, that's just handy for doing things like styling. Anyways, those same IDs are how the callbacks know how to run. So you can see this this div is going to get populated with whatever information comes from this callback here, because that div's ID is the output of this callback. So when this runs, what does it do? So the callbacks are running on an interval, like I just said, every 2 minutes. And what do they do? So that current sensor, which is basically just showing like I'll show you in a second. This one here is calling the API. It's calling the get measurement, get sensor measurement. It's specifying the device ID and a metric. It's doing some processing and it's spitting back this, what do you call this thing? Table, what do you call it? Anyway, it's like an element. It's like a component. They're called components. It's taking the information from this API call and putting it into this component. So you can see here that this latest measurement value comes from this API call. Then I'm putting it into this component so that someone can sit at the front end and see what's my tank's latest measurement value. And it looks pretty. The tanks are 2.5 meters high. This information should really come from config, but I'm showing a demo. It is a demo, it is not production, so this is totally whatever. So that's one. That shows the current reading. There's another one down here that shows the history of readings, and that's on a same idea, except that it goes on this history graph. So this thing goes away. These two calls, API.get sensor measurement and API.get sensor measurement. Notice they're both the same. I just pull the latest one out right here, and this one takes all of them. So I go here. This thing just holds calls to the API. So get sensor measurement and get sensors. So this lets me get all the sensors like I talked about before. This is literally calling the backend method that I specified in the AWS backend discussion. So I can get all the sensors, or I can get the latest sensor measurement. So I'm passing this URL in and getting the result and putting it into a dictionary so that I can process it. So I go away, get the sensor measurements, I put them in a pandas data frame, which is just like a data structure. So it's basically a table. It's a lot like a table. I split these things out so that I can pull out I want to use a timestamp. My Dynamo model includes a timestamp, but it also includes other stuff because of how Dynamo works. So I just split it up, pull the timestamp out, and then put it on this line plot and update the axes with this 25 ticks, so it just looks a bit nicer, and return the figure. So that's pretty much the, so that call is getting a line plot of all the historical data for a particular sensor and its metric, and putting it onto a figure that looks pretty on the UI. So I'm going to switch over and show you the UI. So after all that talking, we have something on a UI which is showing, you can see on the left I've got the current reading. So 1656 is the latest reading coming from the device. And device history, you can see that it's changed a bit. This is literally me moving it around the house. So you can see there's these weird spikes. The device isn't actually changing by 7 millimeters. That's an issue with the resolution on the device sensor. So it actually oscillates by about 10, plus or minus 5. So it oscillates by about a total of 10. So it's accurate to within about 10 mil. These tanks are 2,500 tall, but they're also like 2 meters in diameter. So in terms of water volume, it's the 10 mils a fair amount of volume, but in terms of the total volume, it's totally fine. These water tanks are also fairly slow moving processes, so and there's no control elements sitting downstream of them, so it's not like this 10 mil of movement is gonna be destroying a pump or a valve or anything like this. So this is actually totally fine. And in fact, what really should happen if we were doing that is we should put some deadband processing in, so we wouldn't process changes that are less than 10 mil or something like that. Certainly would put in some dampening on the sensor so that we aren't you know, destroying a valve or something. That's the gist. That's the whole gist. Front to back, there's 3 sensors. I'm only showing one on the screen. There are 3 sensors being processed and stored. I'm showing just one of the devices here, and I'm only showing one metric from one device. So some thinking would have to go in about how to, or like a nice way to present maybe 3 metrics on the same screen and still have it be readable. You can do some pretty cool stuff on these plots here by default. So I actually haven't done anything except default here. You can like pan around. You can like zoom in on stuff. So like if you wanted to get really close in and then like pan down, you could see like, oh, this specific date, this specific time, I took this specific reading. So that's pretty cool. That's the power of Dash, really. That's the power of using a framework like Dash. You don't have to build that. It comes by default. Yeah, that's the whole thing. It's a very long video. All right, thanks.